Hello, my sixth graders. Let's take algebraic operations again. Okay. The first operation that I'm going to take is multiplying a monomial ABC with a trinomial given as follows. This is the trinomial. So you can say basically we are doing polynomial multiplication with a monomial ABC. Alright, let's multiply this. So the first step would be to write the given equation separating the terms by the multiplication sign. So what do we do? First write ABC multiplied by minus 13 a square b square c plus 4 a square b minus 3 ab square c cube. You can put a bracket like this, so that this monomial will be multiplied to each of the terms including their signs. So we have to multiply the monomial with all of the three terms. Basically we are doing distributive property of multiplication over addition or subtraction. So the second step will be write a, b, c, the first term, the monomial multiplied with the first term from the trinomial, 13 a square b square c. Put a bracket. Then write this sign plus as it is, center sign plus. Then the next will be ABC multiplied by 4a square b. The next you can write plus in the center sign. Again write ABC, the first term, that is the monomial, multiplied by minus 3ab square c cube. So we wrote the center signs as plus. Okay, we wrote the center signs as plus. So let's do the next multiplication. So here what we are supposed to do is we are going to use the product law of exponents. So what is the product law of exponent? It says that a to the power m multiplied by a to the power n is always equals to a to the power m plus n. So if the bases are constant or common, the powers can be added for that particular base. Alright, so using the same product law, we can write is equal to the next step. So how do we write? First we'll collect the integer. So what is the integer here? Minus 13. So minus 13 I write as it is. Next I'm writing a multiplied by a square, right? Then b multiplied by b square, and then c multiplied by c. Put that in the bracket. Next you write plus. Then the integer in the next case is only 4. So I am writing 4 as it is, multiplied by a square, b multiplied by b, and there was only a single c which I end up writing like this. So then next one you will write plus. Then the integer in this case is minus 3. So I am writing minus 3, and then a multiplied with a. You can continue in the next part. Then b multiplied with b square, and then c multiplied with c cube. Complete the bracket. It's time to use the product law and simplify further. So I'm writing the next step as minus 13 a plus a to the power 1 plus 2, okay, b to the power 1 plus 2, and c to the power 1 plus 1. Okay, put a bracket. Then you're writing 4 multiplied by a to the power 1 plus 2, then multiplied by b to the power 1 plus 1, then multiplied by c. And then in the next write plus minus 3 a to the power 1 plus 1 multiplied by b to the power 1 plus 2 and multiplied by c to the power 1 plus 3. Closing your bracket. Okay, closing your bracket. So let me just shift the next question a little way down so that we have space for solving. All right, let's see. So what did we do now is, till now we used the product law. Next step, what I'm going to do, children, see here. Minus 13 I will write as it is, a to the power 3, b to the power 3, 1 plus 2 is 3, 1 plus 2 is 3, and c to the power 2. Alright, that's the first one. Then write the center sign plus. You write 4, a to the power 3, b to the power 2, and c. Then minus 3, I'm pulling the minus sign outside, a to the power 2, b to the power 3, and c to the power 4. So that will be my final answer for the multiplication. I repeat, that will be my final answer for the multiplication. Have a look through the entire question once again. See children, I'm going to explain this once again. See here. The first thing what we did is we multiplied this ABC with the first bracket minus 13 A square B square C. So we end up using the product law to get the first term of the answer as minus 13 A to the power 1 plus 2, which is A cube, okay, B to the power 1 plus 2, which is B cube, and C to the power 1 plus 1, which is C square. The next one, we are multiplying this ABC with the second term of the polynomial 4A square B. So ABC multiplied by 4A square B will be 4 written as it is. Okay, A multiplied by A square, A cube, B multiplied by B, B square, and then since there was only one C, we wrote it as it is. The next, ABC multiplied with minus 3AB square C square. So it will be 3 minus, I write down as it is. Then I'm writing A to the power 1 plus 1, A square, B once and B twice here. So B cube and C1 and C3, totally making it C to the power 4. Am I clear children? I hope the first question of the multiplication of monomial with a polynomial is clear with you guys. You are writing and mentioning the product law in this case. Alright, let's go with the second question children. Divide, that's the second question for you. Divide, that's a division operation. So divide this polynomial by the monomial. So what do we do? The first step, we are writing E is equals to 35 m to the power 7 n to the power 6 plus 65 mn minus 5 m cube n cube divided entirely by 5 m cube n square. Alright, it's time to split. So what we'll do, we'll write everything as numerator by denominator, numerator by denominator, numerator by denominator for all the three terms of the numerator polynomial. So we'll write 35 m7 n6 divided by 5 m cube n square. Center sign plus 65 mn divided by 5 m cube n square. Then center sign minus 5 m cube n cube divided by 5 m cube n square. Alright. We can use the quotient law here, or you can use expansion's way of simplifying, Alright, expansion's way of simplifying for such a kind of a question is going to be little lengthy, because you would end up writing m to the power 7 as m multiplied by m 7 times and so on. But if the school is insisting on expansion's way, then we can do by the expansion's way. Else you can use the quotient law. First we'll handle the numbers. 5 ones are 5, 5 sevens are 35. 5 ones are 5, 1 remainder, 5 threes are 15. 5 and 5 cancels. So what we end up getting? 7, okay, m to the power 7, okay, minus 3, n to the power 6, minus 2. I'm using the quotient law in this case, alright, because they were lengthy expansions, alright, plus 13, okay. See, 1 m in the numerator is there and 3 m's in the denominator is there. So if you cancel that m and m, it will become m square in the denominator and 1 n remaining in the denominator. Alright, then minus m cube and m cube gets cancelled, and out of n cube and n square, 1 n remains in the numerator. Alright, you can write n cube minus 2 like this, n to the power 3 minus n to the power minus 2 like that, and divided by 1. That's what is the expansion so far. So we use the quotient law. We are writing a to the power m. A to the power n is nothing but a to the power m minus n. Simplifying this further, what we'd end up getting, 7 m to the power 4 n to the power 4, right, plus 13 divided by m square n minus n, okay, to the power 1, or you can just write like this, n, and put a bracket to the final answer. Let's have a look at the question once again. Yeah, let's have a look at the question once again. So what did we do? We first wrote the entire polynomial in the numerator, whatever is given in the polynomial, and divided by the divisor 5m cube n square. Then we split. Split means everything of the numerator we split by writing it separately, be divided by the denominator. Okay, so we wrote like this. Now 5 ones are 5 sevens are. Okay, 5 ones are 5 13s are. 5 ones are 5 ones are cancelled. It's time to handle the variables. See, you had m to the power 7, m to the power 3, which becomes m to the power 7 minus 3. You had written the 7 already here. Next, n to the power 6 divided by n to the power 2. By the quotient law, it becomes n to the power 6 minus 2. Similarly, we write 13 in the numerator. See here now, this is m, this is n, and this is m cube and n square. So if I cancel 1m and 1n from the numerator and denominator, I would be end up left with, m square in the denominator and n in the denominator. Make sure that you write this m square and n in the denominator only. You cannot write it 13 m square n, otherwise it will get wrong. Then I'm continuing with this minus sign. Okay, so 5 had got cancelled, m cube had got cancelled, n to the power 3 minus n to the power 2 using the quotient law, right? So we write the quotient law in the right. A to the power m divided by a to the power n is equal to a to the power m minus n. You could do the same problem by expanding. What do I mean by expanding? M to the power 7, you can write m into, m into, m into, like that 7 times. N to the power 6, you could write n into, n into, n into, like that 6 times. And then cancel. But that is going to become a very big question. So for such kind of a questions, I recommend using exponents, properties of exponents, or the quotient law, right? Which I have written on the right hand side inside the box. Let's simplify this further. We would end up getting 7 as it is. M to the power 7 minus 3 is m to the power 4. N to the power 6 minus 2 is n to the power 4. Center sign plus 13 divided by m square n, that is already in the lowest form. And then minus n to the power 1, or just simply n. I hope the question is clear, children. So let's quickly see the question number 3. Divide a monomial by another monomial. Okay, it's a monomial divide by another monomial. So why it's a monomial? Because 25 minus 25 x to the power 5 y to the power 7 divided by 6 is not having any plus or minus in between them. Okay, so this is why this is a monomial divided by a monomial. So let's divide. Let's write the first step by separating with the division sign. Minus 25 x to the power 5 y to the power 7 divided by 6. Okay, write division sign in between because you're supposed to do a divide. Then write the denominator. 5x square y square divided by 36. Okay, write is equal to. So whenever you're doing division of fractions or division on algebra, you always follow the keep, change, flip method. Keep means keep the left hand side. Minus 25 x to the power 5 y to the power 7 divided by 6 as it is. Change means change the divide to a multiply. Divisions always should be solved in this way. You change the divide to a multiply and flip the right hand side number. So flip means take a reciprocal of the right hand side monomial. Reciprocal means the denominator 36 will come in the numerator and the numerator will go in the denominator like this. So this procedure is called as a keep, change, flip. Alright, this is keep, change and flip. Alright, keep the left hand side, change the divide to a multiply and flip. Alright, so let's now see if something cancels from both of these numbers. So first we'll handle the integers. 6 ones are 6, 6 6 are 36, 5 ones are 5, 5 minus 5 are 25. Okay, one negative sign remains. So we have an integer minus 5 and we have an integer 6. So let's quickly write that minus 5 into 6. It's time to place our variables properly. So x to the power 5, y to the power 7 divided by, okay, divided by x to the power 2 and y to the power 2. If you wish, you can do the expansions way here because we have space as well as we have, smaller amount of number of variables. So I'm doing by expansions. Minus 5 into 6, 30. Okay. X written 5 times. X multiplied by X multiplied by X, so on for the 5 times. And then Y 7 times. 1, 2, 3, 4, 5, 6 and 7. Can you see that? 1, 2, 3, 4, 5, 6, 7. 7 times y, 5 times x. 1, 2, 3, 4, 5. Entirely divided by, so this is expansion way. X square means x into x, y square means y into y. Okay, now see what are we going to do. We are going to cancel from the numerator x, denominator 1x. Numerator 1 more, denominator 1 more. And 2y's here and 2y's here. So what are you remaining with? You are remaining with 1, 2, 3 x's. And 1, 2, 3, 4, 5, y's. Alright, let's jot this down. So this will be minus 30 x to the power 3. Okay, and multiplied by y to the power 5. So that is going to be our final answer. I repeat, that is going to be our final answer. So let's quickly have a preview of what we did under this category. First we wrote the monomial center sign divided by the next monomial. Then we used keep, change, flip method. We kept the left hand side as it is. We changed the divide to a multiply, and then we reciprocaled the fraction given on the right hand side. Numerator becomes denominator, denominator becomes numerator. After that, we cancel 6 ones are 6 6 are 36, 5 ones are 5, 5 minus 5 are 25. I wrote the remainders minus 5 and 6 here, minus 5 into 6, 30. Then you have in the numerator x power 5, y power 7. So I wrote that as it is. And in the denominator, these two, x2 and y to the power 2. We expanded everything. Minus 5 into 6, negative 30, and x we wrote 5 times, y we wrote 7 times, right? 1, 2, 3, 4, 5, 6, 7 times. And x to the power 2 and y to the power 2 in the denominator after expanding. We did the cancellations, 2 x's, 2 x's, 2 y's, 2 y's from the numerator, denominator. We end up getting minus 30, 3 times x is left, 5 times y is left. So I'm writing minus 30, x to the power 3, y to the power 5 as my final answer. I hope that is clear, children. Let's now go quickly to the last type of question that I have chosen as a column subtraction. Okay, I have chosen as a column subtraction. Alright, let's see. Read the question. Subtract 5x plus y minus z from 18x minus 3z plus 5y. So the from number should always be written first, and since I am doing column wise, I will write 18x minus 3z plus 5y. Okay, let's write the second row. First write the center sign of subtraction here. Now write like terms below each other. So 5x you will end up writing here. Then plus y you will end up writing plus 1y. Then minus z. Okay, minus z, you're writing minus 1z. In subtraction, the first thing that you do is the bottom row signs have to be changed. So plus y becomes minus 5. Minus 1z becomes plus 1z. And plus 1y becomes minus 1y. It's time to handle the integers. Look at the y. So you have plus 5 and minus 1. This plus 5 and this minus 1 because we changed the sign. So that is going to be plus 4. And attach that plus 4 with a y. So plus 4. Plus 5 minus 1 is plus 4y. Similarly, minus 3 and plus 1. That is a minus 2. So you're getting minus 2z. Okay. And then 18 minus 5, which is a 13. So you'll write plus 13, or you just write simply 13x. And children, this will be your final answer. Don't forget to write the center signs. That is the subtraction by column method. Alright, is that clear?